A scatterplot shows the relationship between two quantitative variables measured on the same individuals. An example of two quantitative variables that could be measured would be height and weight. The response variable is the particular quantity that we ask a question about. The explanatory variable is any factor that can influence the response variable. When creating a scatterplot, you will mark the values of one quantitative variable on the x-axis and the values of the other quantitative variable on the y-axis. Each individual's data will be its own individual point on the graph. When examining a scatterplot, the first thing you do is look for the overall pattern, which can be described by direction, form, and strength of the relationship. The second thing you do is look for departures from the pattern, such as an outlier, which is an individual value that falls outside the overall pattern of the relationship. As an example, we are going to examine the following scatterplot. When examining the direction of the scatterplot, the overall pattern moves from the upper left corner to the lower right. In other words, the states in which higher percents of high school graduates take the SAT tend to have lower mean SAT scores. Later on, you'll learn about negative association. The form of this relationship is slightly curved, not linear. The strength of a relationship in a scatterplot is determined by how closely the points follow a clear form. The overall relationship of this scatterplot is moderately strong. 2 points on the scatterplot stand out. These points can be described as outliers since they fall outside the overall pattern. Positive association describes a relationship in which both of the variables increase or decrease at the same time. Negative association describes a relationship between two variables in which the value of one variable increases while the value of the other variable decreases. When two variables are said to have no association, there is no relationship between the two variables at all. Correlation measures the direction and strength of the linear relationship between two quantitative variables. R is always between -1 and 1. R values closer to 0 have weak correlations, while R values closer to 1 or -1 are generally stronger linear correlations. Correlation makes no distinction between explanatory and response variables. It does not depend on which variable is used as x or y. Because correlation uses a standardized form of each variable, it does not matter which variables are used for x and y. Correlation, or R, has no units. Both variables must be quantitative to calculate correlation. Correlation only measures linear relationships, not curved ones. Correlation is non-resistant and is strongly affected by outlying data points. And correlation is not a complete summary of data. In this first example, there is no linear relationship between the data points at all. Therefore, R is equal to 0. In the second example, there is a negative linear relationship. However, the correlation between the data points is not very strong. Therefore, we estimated R to be -0.3. This third example has a moderately strong positive correlation. Therefore, we estimated R to be approximately 0.5. This fourth example has a moderately strong negative correlation. Therefore, we estimated R to be approximately -0.7. This fifth example has a strong positive correlation. Therefore, we estimated R to be approximately 0.9. This last example has a very strong negative correlation. Therefore, we made R -0.99. Correlation cannot always be determined by simply looking at the graph. When you cannot do so, use the following equation. Now it's time to try it on your own. Researchers are curious if the number of hours spent doing homework a night has an effect on students' grades. What would the response and explanatory variables be? Now, create a scatterplot with the data collected from the experiment. The top row is equal to the number of hours spent doing homework a night, and the bottom row is equal to the student's overall combined grade percentage. Describe the scatterplot. Does it have a negative or positive association? describe the correlation, etc.